video first, Trey, the Agentic AI Trade School. 40 projects in 40 days and 40 nights. This one gonna be a good one for the people that's in vulnerability management, trying to get into vulnerability management. It's a mock interview. Like I said, if you want the source code to play with the app, you're definitely gonna need something like this to help you out with your interviews and get good at vulnerability management interviews. Because sometimes they're easy, sometimes they medium, sometimes they're gonna try to drill you. So it's always good to have all of it. And so yeah, that's pretty much what it is. Like I said, you can go to the Agentic AI Trade School, the description. Then we got a free version, you got the paid version. That's the $99 for all 40 source code. You ain't nowhere on the earth where you can get 40 source codes, Agentic AI projects for $99. Even if you went to Udemy and spent $15 3-4 times, you're still not gonna get 40 projects. So do the math and let's get it going. All right, let's do this.
In a high-scale, dynamic environment like ours, false positives are a constant challenge that can cripple remediation efforts. Describe your overarching strategy for efficiently managing and triaging false positives at scale.
Absolutely. Managing false positives scale really comes down to a combination of automation and continuous improvement. One key approach is to implement intelligent filtering and machine learning models that can learn from past data and help automatically identify patterns that lead to false positives. Over time, these models get better at distinguishing between true positives and false alarms. Additionally, we focus on a strong triage process.
Machine learning is a buzzword. I'm looking for tangible implementation. How do you technically integrate these models into your existing vulnerability scanners and prioritization platforms? And what specific metrics do you monitor to ensure their effectiveness?
Great question. To integrate these models effectively, we typically embed machine learning algorithms into the vulnerability management pipeline. This can be done by leveraging APIs or plugins that connect directly with existing vulnerability scanners and platforms. For instance, we can feed vulnerability data into a centralized analysis engine that applies these machine learning models to filter out false positives in real time. In terms of metrics, we monitor several key performance indicators. For example, we look at the false positive rate over time, which helps us see how well the model is performing. We also track the rate of true positives that are successfully identified and the speed at which vulnerabilities are resolved. Another important metric is the reduction in remediation time, which shows how effectively we're prioritizing and addressing genuine threats. By continuously refining these models and monitoring these metrics, we ensure that our vulnerability management process remains both efficient and
You've mentioned
effective.
integrating with existing platforms. Let's discuss specific vulnerability scanners. How do you tune commercial scanners like Nessus or Qualys to minimize false positives for specific environments, such as highly customized cloud instances?
Absolutely. Tuning commercial scanners like Nessus or Qualys for highly customized cloud environments involves a few focus steps. First, you can start by customizing scan policies to better reflect your specific environment. This might mean adjusting the scan intensity, focusing on particular ports, or tailoring the checks to the specific configurations of your cloud instances. Second, you can leverage asset tagging and segmentation. For example, by tagging your cloud
Customization
is metadata that indicates their role, you can
standard practice. I am interested in the technical validation and suppression mechanisms. How do you validate potential findings against your customized configurations? And what processes do you have for automated suppression based on that validation?
Absolutely. To validate potential findings, we typically cross-reference the vulnerability data with your organization's specific configurations and security policies. This can involve checking the context of the asset, verifying configuration files, or even running additional targeted tests to confirm the presence and relevance of the vulnerability. For automated suppression, we can implement rules that exclude certain findings based on predefined criteria. For instance, if a particular configuration is known to be secure or is intentionally hardened, we can set the scanner to suppress alerts related to that configuration. This reduces noise and allows the security team to focus on genuinely critical issues. We also maintain an ongoing feedback loop.
That leads me to prioritization. In a world with infinite vulnerabilities but finite resources, how do you define critical and establish prioritization logic based on business impact and asset criticality?
Absolutely. To establish prioritization logic, we start key business impact metrics and asset criticality levels. This means categorizing assets based on their role in the organization, the sensitivity of the data they handle, and the potential financial or reputational impact if they're compromised. From there, we align vulnerabilities with these asset categories. For instance, vulnerabilities found on high criticality assets, such as those handling sensitive customer data or core business functions, are given top priority. Meanwhile, vulnerabilities on less critical assets might be scheduled for remediation in a more flexible time frame. We also incorporate dynamic risk scoring, which takes into account threat intelligence, exploitability, and any contextual factors. This way, we can prioritize remediation efforts more effectively and ensure that resources are focused where they matter most.
Models often lack context. How do you integrate real-time threat intelligence and exploitability metrics directly into the prioritization framework, ensuring that theoretical risk aligns with actual threat?
Exactly. By integrating threat intelligence and exploitability, prioritization is not just based on theoretical vulnerabilities, but also on real-world threat landscapes. This means we dynamically adjust our priorities based on the latest intelligence about which vulnerabilities are actively being exploited or are trending in threat actor communities. We can also incorporate real-time data feeds and threat intelligence platforms to continuously update our risk models. This ensures that as the threat landscape evolves, our remediation efforts are always aligned with what's actually relevant and urgent. This approach helps us focus our resources effectively and reduces the noise, ensuring that we're always addressing the highest impact vulnerabilities first.
Let's consider a sudden curveball. The board has significantly cut your remediation budget by 40%, yet expects the same or even improved risk reduction. Walk me through your revised prioritization strategy under these constraints.
Absolutely. That definitely requires some strategic adjustments. First, we focus on the highest impact vulnerabilities by refining our risk-based prioritization even further. We concentrate resources on vulnerabilities that pose the greatest risk to critical assets, ensuring that we tackle those first. Next, we'd also look at implementing more efficient compensating controls, such as stronger network segmentation or enhanced monitoring to mitigate risks in areas where direct remediation isn't feasible. We'd also prioritize quick wins, vulnerabilities that can be patched or mitigated with minimal effort and maximum impact. This helps us maintain a certain level of risk reduction without needing extensive resources. Finally, communication and transparency with the board and stakeholders become even more crucial. We provide clear, data-driven insights into how we're adapting and what the expected outcomes are, ensuring everyone understands the rationale behind the revised strategy. This way, we still
when faced with such drastic budget cuts, how do you technically measure the impact of compensating controls versus direct remediation? And what key metrics do you present to the board to demonstrate risk reduction despite the reduced resources?
Absolutely. To measure the impact of compensating controls, we often track metrics like the reduction in attack surface, the number of detected incidents, and the time to detect and respond to threats. For example, if we implement stronger network segmentation, we can measure the decrease in lateral movement opportunities or the reduction in successful exploit attempts. We can also measure the effectiveness of compensating controls by looking at the frequency and severity of incidents before and after implementation. This helps show that even if we're not directly patching, the controls are still reducing the likelihood of a breach. When presenting to the board, key metrics include the overall risk posture, such as the percentage reduction in exploitable vulnerabilities, improvements in detection and response times, and the reduction in incident frequency and impact, by showing a clear correlation between the implemented controls and the reduction of risk.
Good morning. Let's begin. Describe for me, in your own words, your end-to-end approach to vulnerability lifecycle management for a large enterprise organization. How do you go from discovery to verified remediation?
Absolutely. So begin with, the process starts with thorough discovery. We use a combination of automated scanning tools, manual assessments, and their intelligence feeds to identify vulnerabilities across all assets. So once we have a comprehensive list, we move into prioritization, where we factor in business context, asset criticality, potential impact, and threat intelligence to determine which vulnerabilities pose the highest risk. After that, we coordinate with development and operations teams to create a clear remediation plan, setting realistic timelines and ensuring proper testing to avoid disruptions. Once patches or mitigations are implemented, we conduct verification through retesting and continuous monitoring to confirm that vulnerabilities are fully resolved. Finally, we maintain ongoing vigilance with regular scans
That's a
and
general
audits
overview.
to ensure
Let's
that.
get more specific. How do you practically implement risk-based vulnerability prioritization, especially when you have thousands of vulnerabilities in limited resources? What specific metrics or frameworks do you rely on to make those critical decisions on what to fix first?
Absolutely. So when dealing with large volumes of vulnerabilities and limited resources, I lean on a few key frameworks and metrics. First, I often use the Common Vulnerability Scoring System, CVSS, as a baseline, but I don't rely on it solely. I also incorporate business impact metrics such as the criticality of the asset, the data sensitivity, and potential compliance implications. In addition, I rely on their intelligence feeds to understand which vulnerabilities are actively being exploited in the wild. I also use frameworks like the NIST Risk Management Framework or the FAIR factor analysis of information risk model to quantify and prioritize risks in business terms. Another important aspect is the use of risk-based dashboards, which combine all these metrics into a single view, helping to quickly
CVSS
identify
and
the.
business impact are a good start. But let's consider a more complex scenario. Imagine you have a high CVSS vulnerability on a low criticality development server and a medium CVSS vulnerability on a Tier 1 production database holding customer PII. How do you prioritize these, and why?
In that scenario, the key factor is the potential impact on the business and data security. Even though the high CVSS vulnerability on the low criticality development server looks severe from a technical standpoint, the actual risk is lower because it doesn't directly impact critical data or business operations. On the other hand, a medium CVSS vulnerability on the Tier 1 production database that holds customer PII is far more critical. The potential consequences like data breaches, regulatory penalties, and reputational damage are significantly higher. Therefore, in this case, the medium vulnerability on the production database would take precedence. The rationale is that the exposure of sensitive customer data could lead to more severe business impacts compared to the development server vulnerability. Ultimately, it's about aligning remediation efforts with the business's most critical assets and the potential impact on the organization.
Yes, that's a more nuanced approach. How do you practically map asset criticality at scale? Do you rely on manual surveys, automated tools, or a combination? What happens if that mapping is inaccurate or outdated? How do you ensure its reliability?
Great questions. Usually it's a combination of both approaches. For large enterprises, we start with automated tools that can categorize and tag assets based on predefined criteria such as data sensitivity, business function, and compliance requirements. These tools help create an initial mapping at scale. However, we also incorporate manual input from key stakeholders such as department heads and IT owners to validate and refine that mapping.
You
This
mentioned
hybrid approach ensures
outdated
that
mapping.
we
How
capture
do
the
you ensure
nuances
the
and to
You
keep that
mentioned
mapping accurate and reliable over time, we implement regular reviews and updates. This includes periodic audits, continuous feedback from the stakeholders, and leveraging dynamic asset inventories. If we notice any discrepancies or outdated information, we adjust accordingly. It's really about maintaining a continuous cycle of refinement and collaboration, ensuring that our risk-based prioritization remains relevant and effective.
You mentioned dynamic asset inventories. Can you elaborate on how those integrate with your vulnerability management process, especially in a cloud or containerized environment where assets change frequently?
Absolutely. In cloud and containerized environments, assets are highly dynamic. So we rely on tools like cloud native asset management solutions and configuration management databases, CMDBs, that provide real time visibility. These dynamic inventories automatically detect and catalog assets as they're spun up, scaled, or decommissioned. When it comes to vulnerability management, this means our vulnerability scans and assessments are always aligned with the current state of the infrastructure. This dynamic integration ensures that any new asset is immediately scanned for vulnerabilities and that our risk prioritization is always up to date. To handle the constant changes, we also implement automated workflows that continuously reassess and update risk scores. This way, we maintain an accurate, real-time picture of the environment, and we can quickly adapt our vulnerability management efforts to match the evolving landscape.
Maintaining accurate criticality mapping in such a rapid, dynamic environment is challenging. How do you automatically assign criticality to newly created assets, especially if they lack clear tagging? What are the common pitfalls in this area, and how do you address them?
That's a great point. Automatically assigning criticality can indeed be tricky, especially when assets come online without clear tagging or metadata. One common approach is to use a combination of automated classification based on the asset's role, the services it runs, and its network context. For example, assets connected to production environments or those handling sensitive data can be automatically flagged as higher criticality. Another strategy is to implement a baseline risk assessment that considers the asset's purpose and the potential impact of its compromise. Over time, as asset becomes more defined and as more information becomes available, we refine its criticality rating. Some common pitfalls include relying too heavily on static rules or not updating the mapping frequently enough. To address this, we use continuous monitoring and periodic reviews. We also encourage feedback loops with the teams that manage these assets to ensure that the criticality mapping stays relevant and accurate. It's all about balancing automation with human insight and continuous improvement.
Can you elaborate on how these automated classification systems handle completely new types of assets or services that don't fit the predefined criteria? How do you avoid misclassifying them, potentially leaving critical vulnerabilities unaddressed?
Absolutely. When automated classification systems encounter entirely new types of assets or services that don't fit existing criteria, they often rely on adaptive learning and anomaly detection. For instance, these systems can analyze patterns of behavior, network traffic, and the context in which assets deployed. Over time, machine learning models can refine their understanding and improve classification accuracy to avoid misclassification. It's crucial to have a feedback loop in place. This means
Adaptive
that
learning and
when
anomaly
an asset's
detection
detected
are
that doesn't
powerful tools, but they can also generate a lot of false positives. How do you manage the alert volume and minimize false positives without desensitizing your team? What adjustments do you make to the algorithms to improve precision?
Absolutely. Managing alert volume and minimizing false positives is definitely a balancing act. One way to tackle this is by implementing a tiered alert system. So, for example, we can categorize alerts into different levels of severity and then apply more rigorous validation to the higher severity alerts. This way, the team can focus on the most critical issues first. Additionally, we can refine the algorithms through continuous learning. This involves feeding back data on false positives into the system so we can learn and adjust over time.
Welcome. We are looking for someone who understands the full vulnerability lifecycle, not just scanning. Walk me through your process for managing vulnerabilities from discovery to remediation.
Absolutely. So in my approach, I start with comprehensive vulnerability scanning using a combination of automated tools and manual testing. Once vulnerabilities are identified, I categorize them based on severity and potential impact, and then I prioritize them by business risk and asset criticality. After that, I coordinate with relevant teams to develop a remediation plan, track progress, and validate fixes. Finally, I conduct a post remediation verification to ensure that vulnerabilities are fully addressed and that no new issues have been introduced. It's a continuous cycle of improvement and communication.
How do you differentiate between CVSS score and actual risk to the organization? Can you give me an example of a time you had to prioritize a lower CVSS vulnerability over a higher one?
Absolutely. While CBSS scores give a standardized measure of a vulnerability's technical severity, they don't always reflect the actual risk to the organization. So factors like the asset's importance, the threat landscape, and existing controls can shift priorities. For example, there was a situation where we had a medium CBSS vulnerability at a critical internal application that handled sensitive data. Even though its CBSS score was moderate, the potential impact on data confidentiality and regulatory compliance made it a higher priority than a high CBSS vulnerability in a less critical system. In that instance, we focused on mitigating the lower CBSS vulnerability first to protect sensitive data.
Beyond CVSS and asset criticality, what other factors do you consider in your risk assessment and prioritization? How do you account for
Yeah.
threat intelligence and exploitability?
Great question. Threat intelligence is crucial because it helps us understand the current threat landscape, including active exploits and attacker tactics. This means we can prioritize vulnerabilities that are more likely to be targeted. Exploitability also plays a big role. If a vulnerability is easily exploitable or has available proof of concept code, it increases the urgency. Additionally, we consider factors like the organization's existing security controls, the potential for data exfiltration, and even the potential business impact if the vulnerability were exploited. All of these elements together help us form a holistic risk assessment.
You've mentioned remediation. What are your strategies for working with development and operations teams to ensure timely and effective patching or mitigation? How do you handle vulnerabilities that cannot be patched immediately?
Absolutely. Collaboration's key. I usually start by establishing clear communication channels and setting expectations with development and operations teams right from the start. Work closely with them to prioritize vulnerabilities based on business impact and feasibility. For immediate patches, we coordinate timelines and ensure proper testing to avoid any disruptions. When immediate patching isn't possible, we implement compensating controls such as network segmentation, stricter access controls, or enhanced monitoring to reduce the risk. It's all about continuous feedback, flexibility, and maintaining a proactive security posture.
You've discussed patching and compensating controls. How do you measure the effectiveness of these remediation efforts and ensure that vulnerabilities are fully addressed and not reintroduced?
Great point. To measure effectiveness, I rely on a combination of metrics and continuous monitoring. For example, we track key performance indicators like time to remediation, the number of vulnerabilities closed, and any recurring issues. We also conduct regular vulnerability scans and penetration tests to ensure that vulnerabilities are fully resolved. Additionally, we implement change management controls to prevent reintroduction. This includes thorough testing of patches and staging environments and monitoring for any anomalies after deployment. By maintaining the cycle of continuous improvement and validation, we ensure vulnerabilities are truly mitigated and not reintroduced.
Reporting to executive stakeholders is critical. What kind of metrics and insights do you typically provide to illustrate the current vulnerability status and the progress of your remediation efforts? How do you communicate risk posture to non-technical leaders?
Absolutely. When communicating with executive stakeholders, I focus on high level metrics that clearly show the organization's security posture. For example, I provide metrics like the total number of vulnerabilities, the number of critical and high severity issues, time to remediation averages, and trends over time to show improvements. I also highlight risk reduction and the impact of remediation efforts on overall security posture. When communicating to non technical leaders, I use analogies and business oriented language. For instance, I might, compare vulnerabilities to business risks, emphasizing the potential financial, reputational, and compliance impacts. I also provide visual dashboards and summary reports to make the information more digestible and actionable.
Thank you for your time. We'll be in touch regarding the next steps.
Thank you. I appreciate the opportunity and look forward to hearing from you. If you have any other questions in the meantime, just let me know.
You're welcome. We will conclude the interview here.
Sounds great. Thanks again for the opportunity. And I'm here if you need anything else. Have a wonderful day.